Okay, so my name is Willem. I'm a principal engineer here at Tecton. Today I'm going to be talking a bit about some of the lessons we learned while working on Feast. So let me just jump right into it. But before we get into that, what's the story with Feast? Like, what's happened in the last year since the previous apply? Give you a quick summary. We've seen a bunch of contributions to the project. So it's really grown with its functionality set, lots of optimizations in our feature server in terms of performance. We've added data quality monitoring, we've added a Feast UI, but just in general, we've had community contributions from both our end users, so Spark, Postgres, Trino, and a bunch of other connectors and compute engines, as well as from our partners like Redis, Snowflake, Azure, etc. So really, the project has grown a lot in the last year. And adoption has also grown. So folks at Twitter, Shopify, and a bunch of other teams have built their ML platforms on Feast. And consequently, our metrics are also up. So we're seeing more folks in Slack. We've seen a lot more activity on GitHub. So PRs and stars and forks, etc. So it's been really great to see the project really flourish. But along the way, we've learned some things from our users. And we work with our users on Slack and GitHub and community calls. We also run surveys at least once a year, and often we learn things from our users through those surveys. And so I'm going to share 3 of those key takeaways that we've had over the last year or so. The first one was from the 2021 Feast survey. We asked our users, which technologies do you want to use for your online feature store? I think most people have an idea of what the results will be, and this is what we saw. We saw, unsurprisingly, Redis was one of the top requested online feature store storage technologies, databases. And of course, there's a kind of long tail of other technologies. But very interesting for us was Postgres and MySQL. It's right up there with Redis. And it wasn't 100% clear to us why this was the case. So you'd expect a NoSQL database, something that's super low latency, optimized for point lookups, but you wouldn't really expect Postgres or MySQL there because they're often optimized for different use cases. And we have a hunch for why the teams wanted to use these technologies. Perhaps they already have those deployed in production and they just want to reuse them. But we continue to ask our users questions. The other question we asked was, which technology do you want to use for your offline feature store? So where do you want to create your features? Where do you want to build your training data sets? Where do you want to store your historic feature data? And similarly, of course, you had your data lakes, data warehouses, the usual suspects. But similarly, we also saw operational DBs coming into the survey results again. So this is also quite kind of curious for us because we anticipated teams have large amounts of data and they want to use these kind of like ELT stacks or at least analytic stacks to process that data and build training data sets, not operational DBs. And yet they still came back into our survey results in 2021. So the question for us is really, is there some kind of use case here for operational DBs, or are these teams just trying to get to market and the operational DB is just the easiest way for them to do that? Maybe they don't even have an analytic stack. So the question really was, is this a temporary thing or is this a long-term thing that we just don't understand a use case from our users, our feature stores? And so we ran the survey again this year, recently. Actually, I think it's about a month or so ago. And the results seem to indicate that it was, in fact, a temporary period that our users went through. So specifically, if you look at the results, data lakes are slightly dropping off for feature store usage. Data warehouses are booming. So BigQuery, Snowflake, and Redshift, the adoption and our users really want to use those for their offline feature stores. And for operational DBs, it's basically halved. And so when we speak to our users, often they say, yeah, we were using operational DBs as a quick way to get to market. Often the ML team and the product team was the same person. And often or if it's not the same person, often the product teams just didn't have confidence in the analytics stack for depending on that in production. So the key takeaway for us was really analytics stacks are increasingly being used for production machine learning, and product teams have high confidence in analytics stacks, and folks are moving over to those stacks. So that's one lesson. So another conclusion that you can draw, or the next question you'd ask is everyone just using this modern data stack for production machine learning? Clearly, everyone's using data warehouses, and you can assume that the modern data stack is also just being used for production machine learning. If you look at the survey results, it does seem to indicate that there's a massive move towards data warehouses and these kind of like self-serve, serverless storage engines and compute engines. But it's slightly more nuanced when you look at the tools that are being used with these storage technologies. So we asked our users, what tools are you using to transform your data? And if you look at this list of tools, Spark and Panda still dominate, and those are not modern data stack technologies. So even if users are using data warehouses, they're extracting the data from a data warehouse and using Spark outside of that, or Pandas outside of that, or a bunch of other tools outside of that. So if you look at the third item here, bar chart, dbt is there. So there's pretty good representation from dbt. So some folks are using dbts with the data warehouse, but it's not really at the level of Spark and Pandas. And in fact, if you drill into it more, if you look at feature store users that are using dbt, what tools are they using with dbt? Is dbt enough on its own to do ML and to transform your data? And this is what we found. So for dbt users, 100% of them are using dbt with another ETL tool in order to transform their data for ML usage. And almost 70% of them are using dbt with Spark. And so this is kind of an interesting insight for us. It means that dbt is important for these folks, but it's not sufficient. And so the key takeaway for us was really that the modern data stack is not yet enough for production machine learning. And when we speak to these users, there's two use cases that come that are on their minds for why they use ETL tools along with the modern data stack like dbt. It's streaming. Streaming is still the domain of Spark and Flink and a lot of these traditional tools for data processing. And the modern data stack hasn't fully addressed that yet. There are vendors in the space, but they're still finding their footing. And the other is for on-demand or real-time feature engineering. So can you compute features on the fly and low latency? And that's largely unaddressed by the modern data stack. So this was a key lesson for us as well. The third thing we asked our users was, how do you want to integrate Feast for real-time feature serving? Like if you really want features at low latency with Feast, how do you want to architect your system? How do you want Feast to slot in there? And we gave them a bunch of options in terms of service-oriented or library and programming languages, and these were the results. And so what we found was that, surprisingly, Python really dominates in terms of the language that folks want to use. And this is surprising because, of course, Python is slightly slower than the likes of Java or Go in terms of like latency, read-time latency. It speaks to teams wanting to perhaps have an ease of understanding, or perhaps integration and extension for Python is easier, and they're optimizing for delivery and getting into production faster, as opposed to optimizing for latency. And also, interestingly, they want to use a library. So they want to embed Feast as a Python library into existing components in their stack, perhaps a model server, as opposed to deploying a new service. And so another, if you look at the second bar chart here, another interesting takeaway here was, even in the case when they want to deploy Feast with a feature server as a Python as a service, they still prefer to use Python. And that was surprising because, it's a standalone service and often the language doesn't matter. But our takeaway here was, teams often want to fork code and they want to modify code. And often I think they're just more comfortable with Python, and the ecosystem around that is easier to integrate into a Python service than it is for a Java or Go service. And so we spoke to these teams, and we got a little bit more feedback on why they're adopting Python in production. The first was obviously they're optimizing for delivery over performance, and timelines are so slow already that they'll do anything they can to just get into production. The second point was that Python isn't really, excuse me, Python isn't really that much slower these days. Often Python is really just wrapping another programming language. In fact, this is what we do with Feast today. So our feature server is wrapping Go code, and it's pretty much on par with the Go service in terms of serving features at low latency. But most importantly, the Python ML and data ecosystem is vast, and it's not just offline, it's also online. Tools like Ray Serve, tools like MLflow and BentML, all of these are being used in production in an online way at low latency. And being able to integrate these and plug and play these really is valuable to our users. They just want to get to prod, and often in the 0 to 1 use case, they choose Python. So the key takeaway here was teams are doubling down on Python, not just for offline workflows, but for online production workflows as well. And that was very interesting for us. So if you want to get involved with the Feast project, head over to feast.dev. You probably are on the Slack already. The links are on screen. And we're hiring across the board at Tecton. So if you want to work on open source, if you want to work on ML ops, from junior to leadership roles, engineering, product, marketing, developer relations, come and chat to us.